Hello, my name is Pattiya Pibulchinda, and today I will talk about the relationship between welding and wire arc additive manufacturing process. Start from the welding process, which is typically divided into two groups of MIG welding and TIG welding. The MIG welding or metal inert gas is also known as the gas metal arc welding. The MIG welding uses a continuous consumable wire electrode and a shielding gas. The wire is fed through a welding gun, as in the picture on the left. Since the wire electrode also serves as the weld filler material, the wire diameter and composition will vary. The wire choice depends on the variable like the type of metal, its thickness, and the joint configuration. TIG welding shielding gas is typically 75% argon and 25% carbon dioxide. The second process is TIG welding, or tungsten inert gas, or also known as the tungsten arc welding. TIG welding process also use an arc to weld, but a key difference between MIG and TIG welding is that it uses a non-consumable tungsten electrode and a separate consumable filler material. We manually fed a lot of filler material into the weld puddle at the same time with the arc. TIG filler rod composition and size are varies. TIG welding shielding gas is typically consists of 100% argon. In comparison, MIG welding offers a better speed, but TIG welding produces more clean and good-looking welds, but also at a higher price. Let's talk about the metal additive manufacturing, which consists of four types. The first type is laser-based powder bed additive that uses laser or electron beams to melt and fuse the metal powder into a solid. The example of metal powders are stainless steel, nickel, cobalt, titanium, and aluminum, and the powder choice are constantly expanding with more research. The second type is metal binder jetting. This technique jet powder onto the build platform to print objects similar to the 2D inkjet printer. A liquid binder is applied to combine the powder layer by layer to build the desired object. Printed parts are initially fragile and require post-processing sintering and infiltration to be strengthened. The third technique is the sheet lamination. The sheet lamination joins the sheet of material together layer by layer through bonding, ultrasonic welding, or brazing to build an object for virtual or aesthetic models rather than printing for the structural use. The fourth technique is the direct energy deposition, which is a complex 3D printing process. The focus energy source The focus energy source, such as laser or electron beam, is directed at the building materials to melt to melt the material while simultaneously being depositing material layer by layer. This technique is commonly used to repair or to add additional material to existing structure. Let's talk about the wire arc additive manufacturing, which is one of the variations of direct energy deposition techniques. This wire arc additive manufacturing uses an arc welding process to 3D print metal parts. The wire additive manufacturing often uses MIG welding process. Sometimes TIG or plasma transfer are used for more stable deposition. The process is controlled by a robotic arm, and the shape is built upon a substrate material or a base plate, as designed in the CAD model. As printing, the melted wire is extruded in form of beads on the substrate. As the beads stick together, they create a layer of metal material. The process is then repeated layer by layer until the metal part is complete. Wire art additive manufacturing is particularly suited to manufacturing large-scale metal parts, as the robotic arm of the machine has freedom of movements. Moreover, welding wire used in wire art additive manufacturing printing process is significantly less expensive than metal powder used for other 3D printing techniques. Therefore, this wire art additive manufacturing is considerable to be less expensive than other 3D printing techniques for metal. However, the challenge of this technique is the heat management, as printing process involve high temperature. The high temperature causes the buildup of residual stress that is a common problem in metal 3D printing. As the residual stress can often lead to deformation in a component, cooling must be factored into the process, or else the residual stress will be the main point that can be the weak point of the structure and that could cause to failure as using the parts. Also, other cons of this technique is that some material require shielding. When using certain material like titanium, shielding is necessary to create an inert atmosphere to ensure the right building conditions. The wire art additive manufacturing typically produce near-net shape parts that is bilayer, and we can see those parts on the right picture. But the surface is poor surface finish. The surface of the part need to be finished by machining before the actual use. So that could be the additional cost of these techniques. In summaries, between relationship of welding process and wire art additive manufacturing process. The both techniques are the same, as wire art additive manufacturing often use MIG welding process. Sometimes it uses TIG welding or plasma transfer for more stable deposition. The picture on the left, we can see a person manually fed in the wires fed in the wires as MIG process that do the welding process by manual, and the picture in the middle is by the automatic welding process that have the machine automatically weld more materials to connect two pipelines together. And the picture on the right shows the machine for wire art additive manufacturing that we can simply say that is the robotic arm for welding. So actually, the welding is the process of joining two material together by adding more material in. And by adding more material in, those material can deposit on layers by layers that could be additive manufacturing process that is called wire art additive manufacturing. So these two techniques are basically the same concept. And also the wire art additive manufacturing equipment is interchangeable with the welding process. For example, the robotic arm on the right, it can also use for typical welding too, if you program it to weld the part in the exact place to join two material together. As the robotic arm is controlled by the CAD model, but that is totally possible that these two processes are interchangeable.